Hello, everyone, to another episode of NerdRX podcast, and I'm your host, Barkha. And today we are bringing you another technique which is very, very widely used in our labs, and it is FTIR. And to talk more about FTIR, I have today Cameron Jordan with us. Welcome, Cameron, to the show.
It's good to be here.
Awesome. So, Cameron, before we go into the topic right away, why don't you introduce yourself to our listeners?
Okay. My name is Cameron. I am a first year PhD student at The Ohio State University. I just completed my bachelor's degree less than a month ago at the same university. I have been working in a spectroscopy lab since February, working on a project that involves Fourier-transform infrared and the quantification of cannabinoids present in hemp.
So, my very first question to you would be what is FTIR and what about it got you interested in it?
So I was actually more interested in the cannabis industry rather than the specific spectroscopy that we would be doing. But I saw a very good opportunity to work in an analytical laboratory and get the skills that I would need to continue as a professional in the industry. And I just kind of learned all of the material that I needed to in order to use the technology to create models, to collect data, and to ultimately communicate my work. So I got interested in it because I was taking a class for my major, food analysis, and the professor was, I really just enjoyed working with him. And I approached him about working as an undergraduate in his lab, and he agreed. So that's how I've gotten here so far. FTIR is a spectroscopic method that uses the infrared portion of the electromagnetic spectrum. That further, that is broken down into about two um, subclasses of FTIR. There's near infrared and mid infrared. They just utilize different regions of the spectrum.
Okay. And why do we need FTIR? Like, why is it so important and what are its uses?
So FTIR is very useful in compound identification. We do a lot of classification, and it's also very important in analytical laboratories. Organic chemists use it to kind of identify different functional groups that are present in target analytes, and it can just be used to create like prediction models, as in the case of my research.
Okay. And would you be able to run us through the steps involved in FTIR? Like, how long does an actual experiment take?
Yeah, so it depends on the type of FTIR you're doing. In the case of the near infrared that I'm using for my research currently, it takes about 10 seconds to collect a scan.
Hmm.
Right now, I'm trying to just scan whole plant material from the cannabis species and see if the signal is strong enough from that. If the signal is not strong enough, we can further powderize and then just reduce the particle size and see if that works. If that doesn't work, we'll have to move into a further extraction method, and that can take a little bit more time. But it's very quick. That was one thing that I picked up on when I first started working was that wow, it's actually really easy to collect the data for this.
Right.
But in the case of like mid infrared, for example, it can take a little longer depending on what solvent you use to extract the components and how long it takes them to evaporate. Because a lot of the times, uh, mid infrared is used mostly on crystallized samples.
Right. I remember in my PhD, I used to do synthesis, and after our final step, like before going to NMR or mass spec, we would first quickly run to the FTIR to because our compounds had a very distinct carbonyl groups, and if we see the carbonyl group at 1780, if I'm not wrong, we would be like, okay, we have made progress. So it is a very quick and easy, and I think um, like a robust technique to identify your functional groups.
Yes. And like you said, in the case of synthesis, you can use it to monitor the progress of organic
Correct.
reactions. And I just think it's overall a relatively very cool technique.
Yeah. Yeah. And I think it's really underrated, but it gives you a lot of information, especially for us when we used in context of monitoring our reactions. And it was great. Like if you don't see the carbonyl group, there's no point going to the next step of the reaction. Anyways. So, what would you say? Is there any alternative techniques you can use other than FTIR?
So there are actually a lot of alternative techniques to FTIR.
Uh-huh.
Like you mentioned, NMR is it's a rapidly growing field, especially in the food industry, for rapid identification and also quantification. For my project, we actually use LCMS-MS data to serve as our reference data, and that's the kind of technique that we're trying to replace or speed up in the analytical testing process of hemp right now.
So let's talk about the expertise. Is it an easy technique to learn for a completely newbie if someone has absolutely no idea what FTIR is?
Yeah, I can actually answer this from the side of a newbie because
Okay,
I had no idea what infrared was before I even started,
right.
and it was honestly the easiest science that I have ever done to collect data. There was no tricky extraction that had to be done, no derivatizations, no. It was just a very straightforward technique. You scan the what you're trying to analyze, and then you collect the spectra. And then once you've collected enough spectra, you can move on with the modeling.
Okay. And is the analysis part difficult?
So the analysis it can be relatively difficult. We use a lot of multivariate statistics, like I mentioned, partial least squared regression. We're also looking at principal component analysis and SIMCA, which are classification methods. And we are also now looking at more computer based modeling, such as support vector machine and artificial neural network algorithms.
Okay, it sounds like an easy technique to uh, learn. So, what would you say are the advantages and disadvantages of FTIR?
I would say an advantage of FTIR is definitely the time of analysis. You can almost get almost instantaneous results, like in the case of the near infrared, the 10-second scanning. Um, it's very easy for a new person to use. I would say the disadvantages are sometimes the signal cannot be strong enough from some of the target matrices that we are working with. Um, and there can also be a lot of noise introduced into some of the spectra. So you kind of need to know the chemistry behind why does your spectra look like this? Should it look like this? And what does it mean if it looks different than what you expected?
So, how do you deal with the noise issue?
So there are a few different things that we can do. On the hardware side, we can adjust and change some of the parameters that we use to collect the data to make sure that the signal to noise ratio is good enough. There's some pre processing that can be done, noise removal and filters. to kind of filter out some of the noise and kind of pull out more of the specific regions of the spectra that you're looking at. The filtering is a good technique. It gets you more clear spectra, essentially. But before we pre-process our data and before we build our model, we just like to make sure that the spectra is it makes sense.
Okay, so let's discuss the cost associated with it. Is this technique easy to set up in any lab? And once you have the machine, what about the consumables? Is it expensive or affordable?
It's relatively affordable as compared to like an LCMS for for my project. The sensor that I use is about $5,000 compared to an LCMS being 350,000. It also depends on the type of hardware that you're using. So there are a range of infrared devices. So there's more portable options that are relatively inexpensive and I think would be very good options for labs that are growing or just starting out. And then there are also some benchtop techniques that are around 16,000 for one of the portable monitors, and then the benchtops can get very, very expensive, but I don't have an exact cost for those ones.
Right. I remember the FTIR which I was using had a diamond on its base.
Hmm.
And if that diamond would get scratched up, the replacing that was very expensive. So we always had to be super careful while cleaning. And that was the one important thing that we were taught.
Yeah. So, in reference to like the detectors, like you mentioned, it depends on the crystal that you're trying to use as well. Like you mentioned, the diamond ones can be a bit more expensive, but they're generally more reliable and less prone to breaking. For
Mhm.
example, there's zinc selenide crystals that are very easy to break. I haven't done it yet, but and I hope I never do.
Yeah. So, is there a fun fact about FTIR?
There's FTIR is can just be called IR, but
Okay.
the FT kind of makes it more applicable. Before the use of Fourier-transform, it was very hard to interpret the spectra, but a lot of modern compounds, such as like NMR, it's not called FT-NMR.
Correct.
So I think the FT is very specific to IR.
IR. Okay. And as always, my last question to you would be, do you have any interesting articles or protocols or any resources that would help our listeners? And I would link that down in the description.
Yeah, so my lab recently published a paper, kind of what I have been doing in the with the hemp as well. It's called a novel handheld FT-NIR spectroscopic approach for real-time screening of major cannabinoid content in hemp. That was
Okay.
done by my peer mentor, Siyu Yao.
Okay. I will make sure to have that linked down in the description. And well, that was it for today's episode. FTIR is a very cool and easy technique to learn from what we have listened. And I hope, listeners, you found this interesting. And thank you so much, Cameron, for giving us your time and walking us through FTIR.
Of course, thanks for having me on, Barca.
Yes, and listeners, I will catch you next week for another episode for the podcast. And in meanwhile, if you have any suggestions about topic, or if you wish to come on the podcast and discuss a technique, please feel free to email me at barkha@nerdrxpodcast.com. And remember, it's good to be a nerd. Bye.